My dear students, so far we have seen some various methods of solving the system of linear equations. In our previous videos, we have solved the system of linear equations by three methods. First method, matrix inversion method, and then Cramer's rule, second method. And we have solved the system of equations by method 3, Gaussian elimination method. We have solved the system of equations by the following three methods so far. Now in this video I am going to solve the system of linear equations by rank method. That is, we have to test the consistency of the system of non-homogeneous linear equations by rank method, and also we have to solve. First we have to check the consistency of the equations and then we have to solve. You know what is meant by rank of a matrix. I already defined in our previous videos, the rank of a matrix is nothing but the order of the highest non-vanishing minor. The order of the highest non-vanishing determinant is the order, what is the rank of the matrix. If a matrix is of order 3, square matrix of order 3, if the matrix of order 3 itself is non-vanish, then the rank of the matrix is 3. Like that, you have to define the rank of a matrix, the highest order of the non-vanishing minor is the rank. By using the rank method, we are going to solve this system of linear equations. For that, we have to first test the consistency and then we have to solve. For that, we rewrite this equation into given problem into a matrix form. Matrix form is Ax equal to B, where A is the coefficients of x, y, z, equations involving the variables x, y, z, and the coefficients is called the matrix A. A matrix is the coefficient matrix. That is, matrix A is a coefficient matrix. What is the coefficient matrix? A is the coefficient matrix 1, minus 1, 2. 1 minus 1, 2. 1 minus 1, 2. 2, 1, 4. And in the third equation, 4 minus 1, 1. 4 minus 1, 1. This is the coefficient matrix. A is called coefficient matrix. Next, you have to find adding this right side constant also as a column, and that matrix is called augmented matrix. Augmented matrix. Augmented matrix is defined by A and B, A bar B. That is, we have to construct the matrix using the constants on the right hand side also as one extreme column in the matrix. That is, 1 minus 1, 2, 2, 1, 4, 4 minus 1, 1. And by giving us a line, you will add the constant on the right hand side as a column 2, first equation 2, in the second equation is 7, and the constant on the right hand side in the third equation is 4. So this matrix is called augmented matrix. Now we have to find out the rank of the matrix A and the rank of the augmented matrix AB. If the rank of matrix A is defined by row of A and rank of the augmented matrix is defined by row of A comma B, if these two, rank of A and the rank of augmented matrix are equal to the equal, if the rank of the matrix coefficient matrix A and the rank of the augmented matrix AB are equal, then the equation is said to be consistent. Then if these two ranks of these two matrices are equal, then we say that the equations are consistent. This is, then we say that the equations are consistent. This is the test of consistency. If the rank of coefficient matrix and the rank of the augmented matrix are equal, then we say that the equations are consistent. Okay? Now, the rank of the coefficient matrix and the rank of the augmented matrix are equal, then we say that the equations are consistent. And also, if the given equations are having three unknowns, the number of unknowns in the given three equations are 3, that is x, y, z. So this is an equation consisting of three unknowns. Therefore, if the rank of matrix, coefficient matrix A, and the rank of the augmented matrix AB is equal to number of unknowns equal to 3. If the rank of A and rank of AB equal to 3, the number of unknowns, then we say that the equations are consistent and also the equations have unique solution. Number of unknowns are equal 3. In this case, the equations are consistent and has unique solution. For that, we have to solve by rank method. We will see. The augmented matrix is AD equal to 1 minus 1, 2, 2, 2, 1, 4, 7, 4 minus 1, 1, 4. This is your augmented matrix. So, to find the rank of the matrix, we have to reduce this matrix into echelon form. Okay, for that we have to reduce these elements in the row elements into 0. For that, you first make the second, third, fourth row elements at 0. Therefore, you rewrite R3, the row R3 by R3 minus 4R1. You multiply R1 by 4 and you subtract from R3. 4 minus 4 is 0 you will get. So by using this operation, similarly R2 is R2 minus 2R1. You multiply R1 by 2 and subtract from R2. You will get this element 2 becomes 0. Like that, we have to operate row operations using these two rules. First R3, you rewrite the augmented matrix AB. First row you write as it is 1 minus 1, 2, 2. Second row R2 minus 2R1. R2 minus 2R1. 2 minus 2, 0. 1. R2 is 1. 1 minus minus 2. Minus of minus 2 is 2 minus 2 into minus 1 is plus 2. Okay. 1 plus 2, 3 you will get. 1 minus of minus 2 is plus 2, 3. So, this is 4. R2 minus 2R1. 2 into 2, 4. 4 minus 4 is 0. And this is R2 is 7 into 2 into 2, 4. 7 minus 4 is 3. Similarly, R3 minus 4R1. 4 minus 4, 0. 1. Multiply by minus 4. Minus of minus plus 4. You will get minus 1 plus 4. 4R1 is 4 into minus 1. 4 minus into minus 4 is plus 4. Minus 1 plus 4 is 3. And R3 1. 4R1 sorry. 4 into 2 is 8. 1 minus 8 is minus 7. Similarly 4. R3 is 4. Minus 4R1. 4 2s are 8. 4 minus 8 is minus 4. Okay, this is our, after giving the row operations in the rows R2 and R3, we will get the augmented matrix in the form 1 minus 1 2 2 0 3 0 3, okay, 0 3 minus 7 4 like that. Again you can subtract R3. R3 becomes R3 minus R2. 3 minus 3 0, this becomes 0. You rewrite R3, here I can write it as R3 by R3 minus R2. R3 minus R2. Okay. So R3 is R3 minus R2, you will get the augmented matrix AB is equal to first row 1 minus 1 2, 1 minus 1 2 2 as it is, right. Second row is also 0 3 0, 0 3 0 3, and third row R3 minus R2 0 minus 0 0, 3 minus 3 0, minus 7 minus 0 minus 7, R3 minus R2 minus 4 minus 3 minus 7. See, in this augmented matrix, third row is not at all elements are 0 in row 3. If it is the case, rank of the matrix A is 3 and rank of the augmented matrix A is AB is also 3, because all the elements in the third row is not 0. If it is the case, rank should not be 2, because one element is there in the third row, third column. Therefore, rank of A equal to rank of the augmented matrix AB, or 3 equal to number of unknowns. Given equations as 3 unknowns. If it is the case, the equations are consistent. The equations are consistent and have unique solution. Unique solution. The system is consistent and has unique solution. Otherwise, the equations are consistent and have unique solution. For this case, the third element is defined by 7 is that. You equate it by, because it is Z coefficient, 7 is equal to minus 7. Therefore, Z equal to 1. Like that, you have to find out the value of Z. Similarly, second element, 3y, no Z term, X term. Therefore, 3y equal to 3. From this, you get y equal to 1. So, X equal to 1, y equal to 1. Finally, first equation, X minus y. From the first row, X minus y plus 2z equal to 2. From this, you substitute value of z equal to 1 and y equal to 1. Z equal to 1, y equal to 1. Substituting these values, you will get x minus 1 plus 2 equal to 2. From this, 2. X plus 1 equal to, from this, x2 minus 1 is x plus 1. X plus 1 equal to 2. From this, you get x equal to 2 minus 1. From this, x equal to 1. So, x equal to 1. Therefore, the values are x equal to 1, y equal to 1, z equal to 1. Therefore, the solution of the system of equations are x equal to 1, y equal to 1, z equal to 1. That's all. Okay? Now, the next problem, we have to solve the system of equations. First, we have to check the consistency and then we have to solve. For that, the augmented matrix AB is 3 1 1 3 1 1 2 1 minus 3 2 1 7 minus 1 4 5. This is our augmented matrix. Okay. See, to find the rank of the given matrix, the first row, first element should always be unit 1. This first row, first element, you bring that first row, first element as unit element, that is 1. For that, you rewrite R2 into R1 and R1 into R2. So, you rewrite R2 into R1 and R1 into R2. That is, the augmented matrix AB is now, after giving this operation, R2, 1 minus 3, 2, 1 minus 3, 2, 1. And R1 becomes R2, that is 3, 1, 1, 2. And third row as it is, 7 minus 1, 4, 5. So from this, we will write to convert this second row same element to 0, you will get R2 is R2 minus 3R1 as in the previous problem. What is that? R2 is R2 minus 3R1. R2 minus 3R1. Similarly, R3 is R3 minus 7R1. You giving these two operations in the augmented matrix AB, the augmented matrix AB becomes 1 minus 3, 2, 1 as it is, you write. R2 minus 3R1. R2 3. 3R1 is 3. 3 minus 3, 0. R2 1. 3 R1. 3 times of 3 into 3. 9. Minus 3. There is minus of minus plus 9. 1 plus 9 is 10. Similarly, R2. 1 minus 3 R1. 3 times of R1 is 3 2s are 6. 1 minus 6 minus 5. And R2 is 2. Minus 3 R1 is 3. 2 minus 3 minus 1. Similarly, R3 minus 7 R1. 7 minus 7, 0. R3 is minus 3. 7. 7 3s are 21. Minus of 7. Minus 7 is plus 21. Minus 1 plus 21 is 20. Minus 1 plus 21 is 20. Similarly, R3 is 4. 7 R1. 7 2s are 14. 4 minus 14 is minus 10. And 5 R3. Minus 7 R1. Okay, R3 is 5 minus, what is that? 7. 5 R3, 5 minus of 7 minus 5 minus 7 is minus 2. Okay. After giving this operation in the second and third rows, you will get the augmented matrices of the form. Now, R3 in the augmented matrix is divided by 2. So, R3 elements are common. Common divisor 2 you have, therefore, divide R3 by 2. The augmented matrix AB becomes 1 minus 3, 1 minus 3, 2, 1. Second row, 0, 10, minus 5, minus 1. And third row divided by 2, 0 by 2, 0, 20 by 2, 10, minus 10 by 2, minus 5, minus 2 by 2, minus 1. Now, you can subtract R3 and R2. R3 becomes R3 minus R2. The row R3 becomes R3 minus R2. You subtract, what is that? R2 from R3. Next operation is R3 can be rewritten as by R3 minus R2. So augmented matrix now 1 minus 3, 2, 1, 0, 10, minus 5, minus 1, 0 minus 0, 0, R3 minus R2, 10 minus 10, 0, minus 5 minus of minus plus 5, 0, minus 1 minus of minus plus 1, 0. So you can easily see that all the elements of the third row are 0. Certainly row rank should not be 3. The highest non-negative is only 2 by 2. Therefore rank of A equal to rank of the augmented matrix B. Rank of A and rank of the augmented matrix AB is equal to 2, which is less than 3. Number of unknowns is 3. In this case also, the rank of the matrix, coefficient matrix and the rank of the augmented matrix are equal, but less than 3, equal to 2, less than 1 unit. 3 unknowns, but the rank is 2. In this case, the system is consistent, but has infinitely many solutions. In this case, the rank of the two matrices are less than the number of unknowns. If it is 2, the system is consistent and has infinitely many solutions. And as it is infinitely many solutions, for that you have to find the solution, substitute Z equal to T, where T is the real number of. To find the number of infinite solutions, we have to substitute Z equal to T in the equations. We will get the infinite solutions. Okay. Now, the rank of the coefficient matrix and the rank of the augmented matrix are equal, but less than the number of unknowns, which is 2. In this case, the system is consistent and has infinitely many solutions. For that, to find the solutions, we have to substitute Z equal to T. In the third row, there is no variables. In the second row, 10y minus 5z, 10y minus 5z equal to minus 1. So z equal to t, you substitute 10y minus 5t equal to minus 1. So 10y equal to 5t minus 1. If you bring this 5t to the right hand side, plus 5t. So y equal to 1 by 10 times 5t minus 1. This is the value of y. Z equal to t and y equal to 1 by 10 into 5t minus 1. Then we have to find the x from the first equation, x minus 3y, x minus 3y plus 2z. X minus 3y plus 2z equal to 1. In this case, x is minus 3 times of y, you know. Y is 1 by 10 times of 5t minus 1. 1 by 10 times of 5t minus 1, y, plus 2t equal to 1. Okay. So from this we have to find out x. X minus 3. If you bring this 3 into 3 by 10, alright, 5t minus 1 plus 2t equal to 1. From this case you get x minus 15 by 10t minus into minus plus 3 by 10 plus 2t equal to 1. By substituting, by rearranging this, you will get x keep x here, you will take that minus 15 by 10 to the right hand side. This is plus 15 by t minus 2t, and already 1 is there, minus 3 by 10. You simplify, you will get x is, in this you will get the x value by ordinary simplification. So x equal to, if you take LCM 10, 15t minus 20t, 15t 10 into 2, 15t minus 20t. Similarly, plus taking 10 as LCM constant, 10 minus t. So this is minus 5t by 10 plus 7 by 10. So this is nothing but 1 by 10 into 7 minus 5t. This is the value of x. X equal to 7 by 10 minus 5t by 10. So this is the value of x and this is y and value of z is t. So if it is the case, the rank is equal but less than the number of unknowns which is true, then in the case we substitute z equal to t. Using that value z equal to t, you can find y and x. These are the solutions for the system of given equations. That's all about the problem, and I will continue the remaining problems in the next video. Thank you.